Hey 8th graders, today's lesson is 2.4 and 2.5 light waves, and we've been talking a lot in this chapter 2 about different types of light and why we have different types. And in the last lesson we looked a lot about wavelength, and we kind of found out that those waves that are closer together and have a shorter wavelength and therefore a higher frequency, meaning more waves hit a certain spot in a second, okay, those actually have a little bit more energy, and those are the kind of light waves that we see causing more damage versus those other light waves that have a longer wavelength, lower energy, lower frequency. Those ones are causing other changes to things, but not quite to the extent of damage. So they maybe cause warmth or increased kinetic energy or something along that line. Okay, so today we're really going to talk about, all right, kind of revisiting our Australia topic and saying if the sun has all these different types of light waves, okay, which ones are causing damage to us and which ones are even reaching us. Okay, so your learning targets of the 7 types of light found in sunlight, I can identify which of those cause damage to DNA, and I can explain the role of melanin in skin. So we're also going to talk a little bit about the biology of a skin cell and this pigment called melanin and how that helps protect our DNA and our skin. Okay, and then again, we're going to tie that all back to Australia to see kind of why Australia has higher skin cancer rates. Okay, so your very first activity today is your notebook, of course, and you only have one key concept to add to your notebook today. It is key concept 8, so add that to your key concepts page. Number 8 says, a material absorb energy from some types of light and not others. So today we're also going to really talk about what happens when light isn't absorbed. So what are our options there? Okay, moving on to your activity 2 warm up. Okay, we have this diagram here where we have all 7 types of light that we see in sunlight. Again, sunlight has absolutely all the types of light that we know of. And you guys can see which ones actually reach the surface of Earth. Okay, so Earth's atmosphere can absorb some wavelengths of light emitted from the sun. The diagram below shows which types of light are absorbed in the atmosphere and which types of light travel through the atmosphere and reach Earth's surface. Use this diagram to help you think about which types of light could be causing the damage that lead to skin cancer. Okay, so which types of light reach Earth's surface? There's 5, so make sure you guys circle all 5. And then on slide 5, from the types of light that reach Earth's surface, which do you think could be causing skin cancer? Basically, which of those 5 types of light cause damage to DNA? Explain your reasoning. Okay, if you need to, take a second, pause this, complete your activity 1 notebook and your activity 2 warm up. And when you guys are done with those, come on back and we will do activity 3, which is a little sim modeling combo. All right, moving on to activity 3. So what you guys are going to be doing is using the sim to find some evidence today. And then as you guys find that evidence, you guys are going to be recording that data that you guys research into a model instead of your typical data table. So your goal is to show what happens to genetic material when it's exposed to different types of light. So remember that not all light from the sun is going to cause damage to our DNA and our skin cells. So this is going to be models that show which ones cause damage and which ones don't. Okay, so your do now is use the light wave sim to test the effects of different types of light from the sun on genetic material. Refer to the image above to see which types of light from the sun reach Earth's surface. Turn the show energy on. So that's going to kind of help us determine whether or not that type of light is even absorbed or what happens if it's not absorbed. All right, so when you go into the sim, you're going to go ahead and be looking at the sun. Okay, actually you guys are not going to look at the sun. Sorry, I said that. So we're going to go to genetic material first. So let's drag our genetic material up to platform 1. So there's our DNA. Okay, we're actually going to use laser as our light source and turn it on. Okay, so here is laser. Okay, and then if you guys notice, we can kind of change the different types of light that we use in the laser, and that's kind of why we wanted to use the laser on this one. Is with the sunlight, we can't just highlight one type of light that we find in the sun, but with the laser we can. All right, so use the slider to change the type of light the laser emits. I'm going to go ahead and do this for you guys, but before I show you guys the results of this, I want to show you guys your 2 modeling tools. So you have, again, different types that we're testing here. We have gamma rays, X-rays, ultraviolet light, visible light, infrared, microwave, and radio waves. Okay, and we see that these 5 here are the ones that actually touch the Earth's surface. Okay, they go right through the atmosphere, whereas gamma rays and X-rays, they get absorbed by the Earth's atmosphere, so they don't actually reach the surface. Okay, but we're going to test all 7 of these and kind of figure out, all right, which one of these could potentially do damage to our DNA. Okay, so record the results on your modeling tool, investigating light's effect on genetic material. So there is actually 2 modeling tools that you're going to be doing. You have model A and model B, and they're all kind of color coordinated, so you guys can see that there. So if the type of light has an effect on genetic material, so you see some kind of change, you guys are going to do that one on model A, which is right here. You can see that purple color. Model A show how different types of light from the sun can cause different changes to the genetic material. So again, if we see any change at all to our genetic material, this is where we're going to record our results. Okay, back to slide 8. If the type of light has no effect on genetic material, record it on model B. Model B is on slide 10. Again, notice the blue color coordination. Okay, model B, show what happens when different types of light from the sun cause no change to genetic material in a skin cell. So these are ones that if we expose them to this light, there's no change at all. Okay, so that's where we're going to put them here. And then when we are doing our modeling, we also need to use a yellow highlighter to trace the energy on both model A and model B, and that's why we need to have our show energy toggle checked. And then draw an arrow from each type of light box to a change box to show which type of light causes which change. And I'll show you guys that when I do an example for you. So let's go back into our sim. We'll go ahead and we will test just our very first one, which is gamma. So I am going to scroll until I find gamma. So here it says gamma. I'm going to go ahead, make sure my show energy's on, and I'm going to hit on. Okay, so it looks like the DNA is absorbing that because I don't see the yellow arrows coming out of it anywhere. So I'm going to go ahead and inspect. Okay, and that causes damage. So I'm going to go into my first modeling tool A, because this is the one that causes a change. And then I'm going to click and drag all the things I need to show that gamma rays, oh, sorry, I guess we're only doing the types of light from the sun. So if gamma rays were on here, I would drag gamma rays to the type of light, and then I would put damage under the change, and then I would use an arrow to connect it. But gamma isn't one of the types of light that we're using. We're only looking at the 5 types that reach the Earth. And then just FYI with this, you guys can click and drag these, so you guys can just pull them over here. Okay. So again, you'll go through the 5 types of light that actually touch the Earth. Okay, ultraviolet, visible, infrared, microwave, and radio wave, and you guys will test those to see of those 5 that actually come into contact with our skin, okay, which ones cause damage and which ones don't. I will tell you this though, you will not fill up all 5 of these boxes, okay, and you will probably not fill up all 5 of these boxes as well. So some are going to cause damage, some are not, okay, but it leaves 5 boxes open. Total, you guys should have 5 things over here. Okay, or over, excuse me, types of light used up in either no change or change on slide 9. Okay, once you guys are done with those 2 models, again, make sure you guys highlight to show the path of energy. You guys can look at your sim and say, all right, if I look at this one, here's my path of energy. It just goes right into the DNA molecule. Sometimes you guys might see it come all the way through, so you guys would draw your little yellow highlighter all the way through on your image. And then sometimes you guys would see it like bounce off. So again, if that happens on the sim, make sure you guys indicate that with the yellow highlighter on the modeling tool. Here's our light. Is it stopping here, or is it bouncing off, or is it going straight through? Okay, and then finally you guys have these little arrows here, and these little arrows just help you connect. All right, this type of light leads to this change. Okay, you guys can also just draw those if you choose. I don't care, that's fine. Okay, but make sure you guys are connecting these little circles here to kind of show where they should be and where they shouldn't. Okay, so those are your 2 models, and you guys can move on to this question. Which type of light are absorbed by genetic materials? Refer back to your models. Remember, absorbed is where the arrow just stops. So if we're looking at gamma rays are absorbed. Okay, they just stop and they don't go all the way through. They don't bounce off. So you guys would circle, in this case, if gamma rays were on here, you guys would circle gamma as one of your options. So of those 5 that you guys looked at today, which ones are absorbed? Okay. Which types of light cause damage to genetic materials? Again, if gamma rays were one of your 5 options that hit the Earth here, I would circle gamma rays on that one. But you guys, of those 5, which ones cause damage? So circle all that apply. And then which types of light are not absorbed? So you guys might see them kind of bounce off, or you guys might see them go all the way through. Okay, so circle all of those that don't get absorbed. Okay, and then a couple more things. Okay, based on your investigation, can ultraviolet light cause damage? Yes or no? Can visible light cause damage? Yes or no? Can infrared, can microwaves, and can radio waves cause damage? Yes or no? Okay, so then finally a little bit more to the sim. Can a light bulb cause skin cancer? Consider these two claims. Claim 1, light from the sun and light from a light bulb can cause skin cancer, so both of those are skin cancer causing. And claim 2, light from the sun can cause skin cancer, but light from a light bulb cannot. Okay, so if we go ahead and just look at these images, okay, you're not actually going back into the sim for these. You guys can see here's light from the sun as our light source. Here's the light beam. Again, it has all 7 of those types of light that we know of. Okay, and you guys kind of already know with those 7 which ones can cause damage. Okay, knowing what you know about which types of light can cause damage. Okay, here's a light bulb, and it only has visible and infrared. So think about those two. Are those two part of your data? Okay, can visible light cause skin damage? Can infrared cause skin damage? So you guys are just kind of comparing using the data that you just know and saying, all right, can a light bulb cause skin cancer as well? Okay, so do you agree with claim 1 that says both can cause skin cancer, or claim 2? Okay, what evidence supports your claim? So go ahead and answer how you guys kind of came to that conclusion. And then choose one type of light that can cause skin cancer and one type of light that cannot, and then explain why. So again, just kind of go a little bit further with your explanation and talk about what from the sun can cause skin cancer and what do we see in a light bulb that may or may not. Okay. Again, once you guys might need a couple minutes to do this. Obviously, it's a little bit longer section, so if you need to, take a second, pause this video, finish up all of activity 3. It was clear through slide 18. Okay, and then when you come back, we'll kind of wrap up the last couple parts. It's not as long from there. That's by far the longest part. All right, so activity 4 is a little reading activity. It's a very short article called What is Melanin? So this is that little pigment in the skin that we see that kind of makes us tan or not. So you're going to learn about what it is specifically, aside from the definition I just gave you, and then learn about how it can help us protect our skin cells or our DNA. Okay, and answer this question, what did you find interesting in this article? So again, it's a short little article. It shouldn't take you guys long to read, but do a good job reading it. Go ahead, pause this video, and then when you come on back, we will talk about activity 5. Okay, activity 5 is another little sim. So in this one, we're going to actually use melanin to test out what happens when we have melanin in front of our DNA now. So you'll open the sim to learn about how melanin can protect genetic material in skin cells from UV light. Open the sim, drag melanin to platform 1, and then DNA to platform 2. So this is really important because our melanin kind of goes on the outside of our nucleus and our DNA. So the sun is here, and then the melanin, and then our DNA. Okay, it has to kind of create a barrier to protect our DNA. So what we're going to do with this is we're going to put the melanin, which is this little protein molecule right here, and we're going to put the genetic material here. That way the light has to pass through the melanin first before it hits the DNA. So you guys are going to kind of see just what that looks like. Again, you're going to set it to laser. You're going to drag it to UV light because that's one type that causes damage that you guys just found out from the activity 3 modeling. And then turn on the show energy and observe what happens. So again, you guys want this little show energy toggle on so you guys can see those yellow arrows and what happens to them. Okay. Then you guys can go ahead, see what happens to the genetic material. So hit inspect after you turn the light on. And then get rid of the melanin and let the light just hit the genetic material and see what happens. Okay? Then you'll answer this question. What did you observe about the energy from the UV light when the melanin was blocking the genetic material? So what are those little yellow arrows doing when the melanin's there? Okay, and then again, take a second, pause if you guys need, finish up that quick sim for activity 5. When you come on back, we'll do activity 6. Okay, so this is where we kind of tie it all into what we know about Australia. So discussing melanin level bar graphs when studying the connection between melanin levels and skin cancer risk. Scientists group people by how much melanin they have in their skin cells. Below are 2 bar graphs, one for Brazil and one for Australia, so we're back to comparing to Brazil. Each bar graph shows the estimated percentage of the population with different levels of melanin. Examine and annotate this evidence using the questions below to guide you. Compare the graphs. What does the evidence show? How does this evidence help explain why the skin cancer rate is higher in Australia than it is in Brazil, even though the 2 countries get the same amount of sunlight? So again, if you just look at these, we've got percent of the people in Brazil. Okay, so of all the people in the Brazil, what percent have very low, low, high, or very high amounts of melanin? Okay, and then again, of all the people in Australia, you guys can kind of see where everyone sits as far as their levels of melanin. Whoops, didn't mean to click on that. Hopefully it goes away soon. Sorry, technical difficulties. All right, then you guys will answer these questions if we can see them right now. Sorry, guys. Okay. Compare the graphs. What does this evidence show? So what did you guys kind of learn from Brazil versus Australia? Does it have something to do with the amount of melanin in the people's skin in Australia? Okay. How does this evidence help explain why the skin cancer rate is higher in Australia than in Brazil, even though the two countries get the same amount of sunlight? So what does this tell you guys about the percentage of people that are getting skin cancer rates in Australia, even though they get the same amount of sunlight in Brazil? Okay, why is Brazil's skin cancer rate so much lower? Okay, next one you guys have is the ultraviolet map. So this is the world UV light map, and it shows the amount of UV light reaching the Earth's surface. Examine and annotate the map. So this is different than the total hours of sunlight. Okay, use the questions below to guide you. What does this evidence show? And how does this evidence help explain why the skin cancer rate is higher in Australia than in Brazil, even though the two countries get the same amount of sunlight? So here's your world UV map, and then you guys can see where we get the least and the most. Here's Brazil. Okay, here's Australia. Okay, so kind of look at those colors. Tell me what those colors mean for the amount of UV, and then answer this question. What does the evidence show? How does this evidence help explain why the skin cancer rate is higher in Australia than in Brazil, even though they get the same amount of sunlight? So even though they get the same amount of sunlight, do they get the same amount of UV rays? And that's kind of what we're going to explore next. Okay, and then finally, think about this. You guys had 3 claims that I presented to you guys at the beginning of this unit. Okay, explaining why Australia's skin cancer rate is so high. We already kind of eliminated claim 1, meaning Australia gets more sunlight. We found out that, it's not really different than any other places. Like Egypt gets way more, but their skin cancer rate is still way lower. Okay, so let's focus in on claim 2 and claim 3. There is something different about the sunlight in Australia. Okay, based on the data you guys saw today, is that something you guys could agree with? And claim 3, more people in Australia have skin that is easily damaged by light from the sun. So again, think about that bar graph up there. Do you think that's something you could support? Okay, so something to think about as we move into chapter 3. And once you guys are all done, go ahead and do your wrap up. If you have any questions, get them recorded here. Make sure it saves before you hand it in, and you are good to go. I hope you guys are having a great day, and I'll talk to you soon. Bye.